I'm crossing my fingers.
All right. Today, we're going to talk about just one figure, but we're going to do a couple of different things with that one figure. Yesterday, we talked about pyramids, and we really just did the volume of the pyramid, but we talked about how the base could change. Well, the good thing about today is the base isn't going to change. The base is going to be the same for all the figures that we're going to see today, but sometimes we're going to be finding the surface area, and sometimes we're going to be finding the volume, okay, which is kind of what our focus was yesterday. So the figure that we're focused on today is a cone, okay? And because the base is a circle, the base won't change. We'll need the radius. The radius is going to be really important, so you're going to have to pay attention. One of the things that was throwing some people off, even back to last chapter, was sometimes they gave us the diameter. If they give us the diameter, we have to use the diameter to find the radius, okay? The radius is going to be the part that we're going to use today. And then we're going to talk about a couple of other pieces as well. We're going to start off with finding the surface area of a cone. Surface area would be like if I wanted to cover this cone with paper or whatever, right? And not just the physical part of it, but even the circle on top. I want to cover the whole thing up with something, right? And so I can't see what's on the inside. And so that would be the surface area if I was going to cover it up. The formula for surface area is pi r squared. That's going to take care of the circle part, right? That's going to be the part that's on top or bottom, however you want to think of it. That's the circle part. And then the part around the outside edge is this is what we call the lateral area, because it's on the slanted sides or the lateral sides of this cone. And in order to find that, we're going to take pi RL, and we're going to add those two together. So it's going to be the base plus the lateral area. That gives me my surface area, the whole thing. Now, as we look at a couple of things, the one letter that's new here today is the L. The L isn't something that we've seen so far in this chapter. We've seen pi is pretty straightforward. R is my radius. The height that we've been focused on the majority of the time is what we call the perpendicular height. That makes a 90-degree angle with the base. If I'm given the side on the slanted side of the cone, then we call that the slant height. Okay, and that is my L. L represents the slant height. So I'm going to put an L next to the slant height here. Okay, and if we're trying to find the surface area, we need the slant height as opposed to the perpendicular height. And we'll talk about if we're given the perpendicular height, how we can find that slant height here in just a second. Okay, if they give me the radius and the slant height, this is L, this is R, we're ready to go, right? We have everything that we need to find the surface area. So I'm going to go pi times 7.8 squared plus pi times 7.8 times 10. Okay, and I will tell you this. Sometimes, here they're asking for the answer to the nearest hundredth. Yesterday, some of you might have realized this yesterday, and maybe not, because I've had some questions about this on Big Ideas. A couple of the Big Ideas questions, and I think this goes back to Friday's Big Ideas. I don't know if there was any like this yesterday or not, but they required you to put your answer in as an exact answer. And in some cases, you had to put it in as a fraction. So you got like, I can't remember the number, but I think it was like 93.3 repeating as the decimal. But if you put in 93.3, it's not going to give you the answer, okay? You have to put in the fraction that is equivalent to that. And your calculators change that decimal to a fraction. So just make sure you know you have to change that to a fraction as opposed to a decimal. With pies, a lot of times what we'll do is we're going to write our answer in terms of pi. We're not going to go ahead and put it to a decimal. And so here's what we got to do if we leave it in terms of pi. I'm going to show you two ways to write your answer, which we did kind of earlier in chapter 2. First thing we're going to do is we're going to take 7.8 squared. So if I take 7.8 squared, what do I get? Addie, what'd you get? Did you do it? Okay, 60.84. And then I'm just going to leave a pi on there. I'm not going to multiply by pi yet. Okay, I'm just going to leave it in terms of pi. I'm going to do the same thing over here. Now, this is kind of nice because I'm multiplying by 10. 7.8 by 10. All I do is move the decimal one place over when I multiply by 10. So this becomes 78 pi. Okay, we can then add those two together, and we get 138.84 pi. And we're talking about area here, so that would be meters squared. Okay, that is, if they ever ask you to leave your answer in terms of pi, that means we're never going to multiply by pi on our calculator. We're just going to leave pi on our answer. And we can add these two together because they both have pi on it. All I add is the number in front, coefficient, right? It's kind of like adding 2x and 3x together. We get 5x. That's pi is considered to be my coefficient, or my variable. But if we put that into our calculator, then we'll take 138.84 times pi. And we get about 436.18 meters squared. So both of those, it's kind of like, we've talked about this before. I can write an answer as like a radical, like I can say radical 7, that would be my exact answer. Or I can take the square root of 7 and get a decimal, and that would be my decimal answer, okay? So this would be the exact answer. This would be my rounded or decimal answer. Both of them would be okay. It just depends on how the question's asking us to write our answer, okay? The reason I would do all of this work is because if you try to type this whole thing in all at once, it kind of depends on your calculator. Some calculators do it better than others. Some of you might be able to type this whole thing all at once and get to this answer. Some of you may not, okay? And so you guys kind of have to play around with your calculator. I like to kind of break it up into smaller steps, especially if we're leaving it in terms of pi. Okay, I don't think we need to do the one on the right. I'm going to skip a couple of problems today. The one on the right basically is the same thing. They give me L, they give me R, and so everything that you need is given to you. Okay, on this one here, there is no cone drawn. You don't necessarily have to have a picture, but if you want to draw a picture, you can. Doesn't have to be anything special. Here's the part that you got to be careful of, okay? They tell me the radius is 3. They tell me that the height is 4. The height is your perpendicular height. It doesn't say slant height, it says height. So that's where you got to read these problems carefully. Which height am I given? There's two different types of height when we talk about cones. Okay, so this is the regular height. Now what we know about the regular height is that it's perpendicular to the base, okay? And so it would be perpendicular to my radius. We're trying to find out what L is. We're trying to find that slant height. Now here's the good thing. It has a right triangle, and we're trying to find the slant height of that right triangle. What would be the best way? What's something that we can use to find L, the slant height? What's something that we have, that we've used, that we can? A squared plus B squared plus C squared. Good old Pythagorean theorem, right? So over here I can do 4 squared plus 3 squared equals L squared. So this would be 16 plus 9, which is 25. So my slant height is 5. You won't always get a nice whole number for your slant height, okay, but in this case we do. Okay, so now we want to find the surface area. So we're going to go pi times 3 squared plus pi times 3 times 5. 3 squared is 9 pi. 5 times 3 is 15 pi. So then 9 pi plus 15 pi is 24 pi. And then we can put that into our calculator. What's the decimal? 75 point.
0.4 because it's 398.
Okay. So 40, and then our label, it doesn't give us feet or inches or anything here, so we're just going to use a generic label of units squared here. Okay, even on big ideas, like if we have a situation like that where it's like 398 and it rounds up to 40, make sure you put the 40 in here. I think sometimes big ideas count you wrong if you don't put the 0 there because you're going to the nearest hundredth, so you have to put 2 decimal places there. I don't know that to be true always, but I know that I've seen that before where big ideas counts are wrong. Even though 75.4 and 75.40 are the same thing, they want you to write it to the nearest hundred. So be careful of something like that as well. Okay. Second thing that we're going to do with the cone, all we're focused on today is a cone, okay? Second thing that we're going to do is now finding the volume of it, okay? We're going to try to figure out how much can I put into this cone. And kind of like yesterday, I could bring a cylinder out that has the same base as this, and I could say, well, how many of these cones would it take to fill up that cylinder, right? Well, as long as they have the same base, it would take 3 of these to fill up a cylinder with the same circle base, okay? And so this is 1/3 of the volume of a cylinder. And so the formula is the same formula as yesterday. It's going to be 1/3 big B times H, or because big B here is a circle, we can go ahead and put the formula for area of a circle in here, and it's pi r squared. That's the good thing about today is our base is the same every time. We don't have to decide, is it a square, is it a triangle, is it a hexagon? Yesterday our base changed every single problem that we did. And so once again, not really anything new here. We got to know the radius, we got to know the perpendicular height. We don't really need the slant height here, okay? Because we're finding the volume. So let's look at the very first one. Actually, let's look, we'll skip the first one, go to the second one. My radius is 7. My height is 13. So we have R, we have H, we're ready to go, right? We have everything that we need to find the volume. So that's always good news when we have everything that we need. Okay, if we were going to leave this one in terms of pi, we would take 49 times 13 and then divide it by 3. Okay? If you were to do that, then you're going to get a fraction here, I think. And so you'd have to leave it as a fraction with pi. But let's just go ahead and type that whole thing in at once here. We're just going to round to the nearest hundredth. Make sure you're practicing putting this into your calculator so you know how to type all of this in. Okay, what do we get?
667.
Okay, good. And then we'll label it here. We're talking about volume, okay? So on the previous page, we were talking about area, surface area, so we did squared. Here we're talking about volume, so it would be inches cubed for our answer. Okay, what's different about the one on the right here?
Upside down.
It's upside down, okay. What else? if I'm going to find the volume,
Oh, that's the slant height.
it's the slant height. Yep. We don't know h. Okay? So we have to find h. So it's kind of like the one we did just a few minutes ago where we had to find the slant height. Here we're given the slant height. So once again, we can do the Pythagorean theorem. Okay? I've seen some issues with Pythagorean theorem. Remember, if here's my 90-degree angle, this is my longest side. That's always the side that goes over here by itself. So be careful where you put the numbers into the Pythagorean theorem at. It's not 8 squared plus 5 squared equals h squared. Okay? So you got to be really, really careful about that. The slant height will always be your hypotenuse in this case. So we have h squared plus 25 equals 64. H squared equals 39. Okay, now here's what I would do. I would leave it as the square root of 39 for right now. Okay, here's what happened on the test last week. Some of you, you would do a problem like this and you would get the square root of 39 and it gives you the decimal. Okay, and the decimal for the square root of 39 is 6 point something. So you would write the decimal 6 point whatever and you'd round it to the nearest tenth or the hundredth or whatever. We want the answer as close as possible to the actual answer. So just leave this in your calculator, okay? Leave the square root of 39 alone. Don't round until the very end of the problem. So we're going to go volume equals 1/3 pi times 5 squared times the square root of 39. Okay? So put that whole thing into your calculator and let's see what we get. Hello. No, not here. Okay. Yeah. Okay. Yeah. I don't. She didn't send anything to me or anything. So. Okay. Yeah. No problem. Have you seen Chai today?
No.
Yeah.
I think she said something about being gone yesterday.
Yeah. It's. Okay. Okay, so here we should get about 163.49. Does that sound right? Okay. Everybody good? Calculator-wise, punching that in? The problem here would be if you rounded this, your answer is going to be close to this, but it's not going to be exact, especially in big ideas. If you try to put in the answer as a rounded answer, then you're going to have the wrong rounded answer. It's going to be off just a little bit. So just be careful of those kind of things. Okay. Yesterday, we did some volume problems like this. Going back to Friday, we did some surface area and volume problems, and we're going to go back today and do both again. It's the same routine, okay? Now we've seen them several times, and we're going to continue seeing them. We're just doing it with different figures. The type of figure that I have, it does not matter, okay? When you do ratio to area to volume, you set all of these up the same way. And the very first thing that I'm going to do is set up my ratios. So I have similarity ratio. I have an area ratio, which normally is surface area. Keyword is area. They call it surface area, but area. And then volume. Okay? Those are my three ratios that I'm going to need to figure out. The first ratio is comparing any sides from the cone. Okay? We can't just find the volume because we don't know the heights of these cones. So I can't just look at the cone and say, oh, I know the radius, I know the height, I'm just going to plug it into the formula. You can't plug this into the formula because you don't know the height, okay? So that's not an option. So what we have to do here is we have to set up a proportion to get there, okay? So I got to figure out what those proportions are going to look like. So first up, we're going to compare the two radii. The radii of the small one to the radii of the big one is 3 to 9. If I reduce that, it would become 1 to 3. So we're essentially saying cone B is 3 times larger than cone A. That's all that means, okay, when you write that ratio. When I do the area ratio, area is always squared. So we're going to do 1 over 9. I square the top, I square the bottom. When I square 1, it doesn't change it. It's still 1. If I had a different number other than 1, that number would change. But 1 squared is 1, 3 squared is 9. Now here's the problem that some people were doing yesterday, and here's where they were making the mistake. When they went to their volume, they were trying to cube this number. We go back to the original area, or original ratio, 1 over 3. That's the ratio that I cube. Volume is always cubed. So that would be 1 over 27. Okay, they're not asking me for the ratio. They're asking me for the actual area and volume. Okay, so that's what we're going to do down here. We're going to find the area and the volume of cone B. So let's do area, first of all. Well, if I'm finding area, I'm going to use the area ratio, 1 over 9, from up above. Morning. Thank you. And then it tells me the surface area of the small one is 24 pi, okay? Pay attention to that pi. That pi is part of my surface area. But it's the surface area of the smaller one, right? So 1 is smaller than 9. So I'm going to put 24 pi up here, and I'm trying to find the bigger one, okay? Small to big, small to big. Some of you might would rather write 9 to 1 instead of 1 to 9. It really doesn't matter as long as you stay in the same ratio. Small to big, or big to small, you'll get the same answer. Okay? When I cross multiply here, it doesn't say how to write my answer, but because the original surface area and volumes are written in terms of pi, I'm going to write this in terms of pi. So that would be 216 pi b squared. We just leave pi on our answer. Okay? If I had to put that in my calculator and get an answer to the nearest hundredth, then I could do that. That's not a hard thing to do there. Okay, volume is going to be set up exactly the same way, but you have to do a completely different proportion. And instead of using 1 over 9, we're going to use the volume ratio, which is 1 over 27. Okay, so we're using the ratio that we just came up with up here, and we're bringing it down here. The volume of the small one is 12 pi. So 12 pi is the volume of the small cone. I'm going to put 12 pi on top because 1 is smaller than 27. So I'm going small to big, okay? And we're going to put x on bottom. Once again, when you cross multiply here, you don't need to multiply by pi. All you got to do is take 27 times 12. If there was some number here other than 1, I would divide by that, but dividing by 1 doesn't do us any good. And so this would just become 324 pi. Okay. I think I'm going to skip this top one up here because it's basically the same thing we just did. You just got to write your 3 ratios out and then find out your surface area and volume. So that's the one we just did. Same thing down here. Probably won't do both of these. We'll pick one, and both of them are essentially the same problem. You got a cylinder on bottom and you got a cone on top. Okay? I am only finding the volume here. Okay? So if I put a cone and cylinder together, I want to know what's the total volume. It kind of looks like a grain bin. I grew up on a farm, and then basically that's what you have here. You got grain bins have like a cylinder base, right? And then as it comes to the top, then it usually has kind of a cone on top. A lot of grain bins even have a cone on bottom that kind of goes down into the ground a little bit. So you're trying to hold grain, right? You're trying to put as much grain in there as you possibly can. In this case, we don't have a bottom cone. We just have a cone on top and we have a cylinder in the middle. Let's do let's do the one on the left, okay? We're going to do the volume of the cylinder plus the volume of the cone. Okay, the cylinder. To find the area of a cylinder, that would be pi r squared h. To find the volume of the cone on top, that would be 1/3 pi r squared h. The first and most important part of the whole problem is make sure you're using the right formula, right? If I don't use the right formula, then it doesn't do any good to plug some numbers into a formula that's not the correct formula, okay? And we have two different formulas that we're using here. One's a cylinder, one's a cone. I'll keep reminding you, on the very back page, if you don't remember some of these formulas, the very back page of your packet, you have a formula page, okay? It goes back and has everything from chapter 12 that we've done in there. Okay, make sure that when you do the cylinder, I'm not paying attention to the cone up here, okay? So the radius is 6. The height of the bottom, the cylinder, is 5. So this would be pi times 5 squared, 6 squared, times 5. Okay, over here, the radius is still 6 because they have the same base, but the height of the cone on top is only 4. So they don't have the same height. When I look at the cone on top, the height of the cone is only 4. Okay, the height of the bottom is 5. I'm going to kind of do this like I did earlier in the lesson. 180 pi, 6 squared is 36, times 5 would be 180. And then here, 36 times 4 divided by 3, or times a third. That'd be 48 pi. Okay, we're going to add those two together. We're talking about volume. So that would be one way I could write my answer. That would be if they ask for the answer in terms of pi. We don't have to put pi into our calculator, or we can go ahead and take 228 times pi, and we get 716.28 meters cubed. The one on the right is basically the same thing, but just different numbers. So I don't think there's really anything there different to do. Okay. I haven't given you a whole lot of time to work the last couple of lessons, so I'm giving you a little bit more time today.